Welcome to our channel. Today we will be discussing about acids and bases. Well, acids and bases are not as simple as sour and bitter, and it is not as simple as lemon juice and soap. To begin with the video, at first you must know what is classified as an acid and what is classified as a base. Actually, there are multiple theories revolving this fundamental question. But don't worry, we will only explain to you two of the most common theories that is enough to explain most acid-base reactions. The first one is Arrhenius theory and the second one is Bronsted-Lowry theory. Arrhenius theory states that acids are substances that produce hydrogen ions in water, while bases are substances that produce hydroxide ions in water. Look at the reaction of dissociation of hydrochloric acid in water. The reaction produces hydrogen cations and chloride anions. Thus, hydrochloric acid produces hydrogen ions in water and is classified as an acid. The other reaction will be the dissociation of sodium hydroxide in water. The reaction produces sodium cations and hydroxide anions in water. Thus, sodium hydroxide produces hydroxide ions in water and is classified as a base. On the other hand, Bronsted-Lowry theory states that acids are substances that donate proton or hydrogen, while bases are substances that accept proton or hydrogen. Consider the reaction between HCl acid and water that produces hydronium and chloride ions. Hydrochloric acid donates proton to water and water accepts it. So hydrochloric acid is an acid and water is a base in this reaction. Due to the donation and accepting of the proton, this reaction produces hydronium ions and chloride ions, where hydronium ions are the conjugate acid of water and chloride ions are the conjugate base of hydrochloric acid. Well, these two theories can describe well the definition of acid and bases. Now, let me explain about the pH scale. The pH scale is a simple and effective way of representing the concentration of hydrogen ions in a solution. Comparing values of hydrogen ions or different substances relative to water can result in ratios that are difficult to comprehend. So, scientists develop a logarithmic scale to display hydrogen ion concentration results in a simple visual scale that is accessible to non-scientists and valid for scientists as well. As the pH scale is a logarithmic scale to base 10, a change of 1 pH unit is equivalent to a tenfold change in the hydrogen ion concentration of a substance. So it can be inferred that a small change in pH solution represents a large change in the hydrogen ion concentration. Here are two problems involving the calculations of the pH scale. So in the first problem, we can find the hydrogen concentration through using the initial pH formula through the logarithmic scale, which yields us the answer 2 times 10 to the power of minus 7. And then after we consider the auto-ionization of water constant, which is 1 times 10 to the power of minus 14, then we can find the hydroxide concentration. In the second problem, to find the pH from the given hydroxide concentration, first we will need to find the hydrogen concentration first from dividing the auto-ionization water constant by the hydroxide concentration itself. And then we get the result 1 times 10 to the power of minus 12, and that yields us the pH of 12. Acid deposition is a process by which acid-forming pollutants are deposited on the Earth's surface. Increased industrialization and economic development in many parts of the world have led to rapidly increasing emissions of the nitrogen and sulfur dioxides that cause acid rain, the most prevalent form of acid deposition. So, rainwater is naturally acidic due to the presence of dissolved carbon dioxide, which forms weak carbonic acid. CO2 plus H2O yields H2CO3, weak carbonic acid. Acid rain results principally from the formation of two strong acids, nitric acid HNO3 and sulfuric acid H2SO4. Nitric acid is created from nitrogen dioxide, in which it reacts with oxygen in high temperature to form nitrogen monoxide, which react again with oxygen in atmosphere to create smoke, or we known as nitrogen dioxide. And nitrogen dioxide will react with water to eventually form nitric acid. And nitric acid is somehow acidic. It has a pH of like 5, which can disturb the aquatic life because fishes cannot live in acid condition. Sulfur dioxide also contributes to the production of acid rain from chain reactions. First, sulfur will react with oxygen to produce sulfur dioxide. Then the sulfur dioxide will react with other oxygen to form sulfur trioxide, and this sulfur trioxide will eventually react with water to form sulfuric acid. In the end, sulfuric acid and nitric acid will combine to form acid rains, which is harmful for the environment.